Hi learners, welcome to Virtual Computer School channel. In this video lecturing, we are going to discuss about two topics. One is keys and next one is relational algebra. First, we shall discuss about keys. When we create any database table, the keys are playing vital role. Okay, suppose if you create a student table with student registration number, student name, and student date of birth, phone number, email ID, and address. Okay, so with this attribute, if you create a student table, and based on certain values and based on the accessibility, we'll be using different types of keys. Okay, so first we'll speak about primary key. What is a primary key? The primary key is the one of the important key that we use in the any table, and this primary key should be with unique keys or unique values. Okay, for example, in the student table, the student registration number will be unique values. Okay, there will not be any duplication in the values. If you find any particular column or any particular attribute in the table with unique key values, then we can make it as a primary key, right? So this primary key will be mostly used when you are accessing your table using SQL queries, right? Then next comes the super key. The super key is a set of one or more columns to uniquely identify rows in a table. There are sometimes you'll be having more number of columns or more number of attributes with unique values. Okay, for example, your student registration number and then phone number or email ID. So this will be with unique values, right? When you combine these unique value attributes or the column, then you can make it as a super key, right? Then candidate key, a super key with no redundant attribute is known as candidate key. So when you have the super key, generally in the super key, you'll be getting the unique identifier, that is unique values. Suppose if there is no redundant, okay, so the condition here is the candidate key can be a super key with no redundant attributes. You know what I mean by redundant attributes? That is the attribute value should not be repeated, right? You should not have more than one value there, right? So in that case, you can make it as a candidate key. Then alternate key. Alternate key, maybe in the place of primary key, you can choose any one of the other key for accessibility. That is why we call as an alternate key. That is, out of all candidate keys, only one gets selected as a primary key. So we already said about what is a candidate key. The candidate key without any redundant attribute can be considered as a candidate key. Among the candidate key, suppose if you choose any one of the attribute as the another key or accessible key, then you can make it as an alternate key. Okay, so the alternate key or otherwise called as a secondary keys. Okay, then the next one is composite key. Composite is, maybe you can have it as a group, maybe more than one, right? So a key that consists of more than one attribute to uniquely identifies the rows, also known as records and tuples in a table, called a composite key. Suppose if you use, for example, in the student table, if you use student registration number, and suppose the student registration number will be there, and then suppose if you use student name, the student name, maybe there is a possibility with the same initial and same surname or the last name, there can be more than one name may be possible in the name attribute or name field. Okay, so in that case, what you can do, you can combine one more attribute, for example, date of birth. That is, your name and then date of birth can be combined to make it as a unique value. Okay, so in that way, you can call it as a composite key. It is a composition of more than one key or more than one field in the particular table. And next comes the foreign key. The foreign key mainly you are using when you are going to relate one table with the other table. Okay, suppose in the relational database model, we already spoke about. In the relational database model, we'll be having more number of table, and each and every table must be related, must be connected with one another. Okay, there should be a communication between one table with the other table. Okay, so how the communication takes place between one table with the other table? By means of foreign keys. Okay, the foreign keys are the columns of the table that points to the primary key of another table that act as a cross reference between the tables. Okay, so here, for example, you have the student table and then the other course table. Okay, so in the student table, you'll be having the primary key, and then the course table, you'll be having the course ID. Okay, to have a reference between these two tables, you have to have a connectivity. Okay, so here the course ID of your second table, that is your course table, can be acting as your foreign key. Okay, so we'll just explain the keys with this diagram a little bit more. See here, you have the ID, roll number, name, enrollment number, address, and department ID. These are the attributes and then fields are in this particular table. And you have one more table also. That is department ID, name, and address. Okay, so now we'll see what are the different types of keys we are using in the table. The one is the primary key, that is ID number. ID number of your student will be taken as the primary key. And then even sometimes if you want to make it as a roll number, that is also can be considered as your primary key. Okay, so in this example, the ID number is taken as the primary key. And then the other, what are the other alternative keys? You can take roll number or the enrollment number. Okay, the roll number as well as the enroll number will be also unique key, so you can make it as an alternative key. Okay, so here the unique key, enrollment number is also unique key. We call it as a unique key, right? So when you combine the primary key, maybe you can consider ID, or you can consider roll number, or you can take enrollment number. So this combination you can make it, you can call it as a super key, right? So here you have the two tables, right? So here you have the department ID in here also, and here you have the department ID. Okay, so now the department ID of this particular table, the second table, is actually working as a foreign key in the first table. Okay, so it has a reference, right? So here foreign key relationship, you are making a foreign key relationship between these two tables. Okay, so what are the other possible candidate keys are there? So that is possible candidate key, either you can make it as ID or roll number or your enrollment number. Okay, so all these three fields are unique, having unique key, unique values. Okay, so you can consider as an possible candidate keys, right? So this is the concept we need to understand in the key concept. Okay, so when we study about key, we need to understand this. The other in this diagram also there are other points also discussed. The same thing, like what is the primary key, what are the different candidate keys you can use it, right? So what do you mean by a super key? What is a unique key? So what are the alternate keys? Okay, the composite key, one more composite key we have here. So it is a combination of two different field. Okay, employee ID and salary and month year. Okay, so here the employee ID will be acting as your foreign key in this particular table, right? So this how these are the some of the list of important keys we need to understand. Okay, so this very much will be very much useful when you design your databases and when you write your SQL queries. Okay, right. So next we'll move on to the next topic, that is relational algebra. See here we need to understand first of all, what is the relationship or what is the connectivity between our relational database management system and then relational algebra. Okay, so here generally the relational algebra, whatever the mathematical concept, that is actually the base and fundamental for creating a relational database management system. Okay, so we are talking about database management system and then relational database management system, right? So database management system, it is a somewhat older one, and after that when you are trying to connect between different types of or different table, then you can make it as a relational. That is, you are making a relationship between one table with the other table, right? So here that is why the name came, right? So relational algebra or a relational database management system, the fundamental idea from where we have designed the relational database management system is from relational algebra concept. Okay, so here in the relational algebra concept, it is a mathematical background where we are going to apply all the relational algebra concept in the relational, that is query, whatever the SQL query we are writing. So in the SQL query, we'll be implementing the relational algebra concept. Okay, the relational algebra consists of several group of operations. We'll be studying about different operations here. That is, one is select, project, and rename. Okay, so select is somewhat equivalent to your select statement. Project is also we are going to study, and then the rename is also we are going to talk about. This all comes under unary relational operations. Okay, then next to that we are going to discuss about relational algebra operations from set theory. Okay, so in the mathematics you would have studied about set theory, A union B, B union C, A intersection C. Okay, so those set theory concept also we are going to apply here for the database accessibility, right? So here, what are the relational algebra operations we are going to study? Union, intersection, difference, and Cartesian product. Okay, so the Cartesian product, also called as cross product, right? And then actually in the slide you can see binary relational operations, that is join, division, and additional relational operators, outer join, and aggregate functions. Okay, see, for aggregate functions there is a separate video is posted. You can just have a reference for that particular topic, aggregate functions. And the binary relational operations, that is join, division, and outer join, this is also will be you can see in the other video. Okay, so in this video we are going to discuss only the unary relational operations, that is select, project, and rename, and then relational algebra operations, that is your union, intersection, difference, and then Cartesian product also we are going to cover. Okay, so let's start with the relational algebra concepts. So in the relational algebra, the basic is the basic set of operations for the relational model. That's why I told you. So this is actually the basic for, so how we framed or how the relational database management system model was created. Okay, this is actually the basic idea, right? So whatever the concept you are studying in the relational algebra, so most of the concepts are used in the relational model. Okay, so these operations enable a user to specify basic retrieval request. So whenever you write any query, so this query will be understood by the relational database management system in the form of relational algebraic expressions. Okay, so we are going to discuss about what is relational algebra and what is a relational algebraic expression and all, right? So whatever the query you are writing, or whatever the query you are using in the database management system, so these queries will be understood by the database management system in the by the means of the relational algebraic expressions. Okay, the result of an operation is a new relation which may have been formed from one or more input relations. So obviously in the relational database management system or in the model, we'll be using more number of table. Okay, so when you perform the relational algebraic operation, at the final output or the final stage, you'll be getting one complete relation or the table. Okay, so as you know, in the relational database model, when you use the term relation represents a table. Okay, so relation represents a table, right? So when you have more number of tables, suppose if you use select statement, and then if you use insert or update or whatever the SQL statement, so after executing all your statement, finally what you will get, based on the commands or based on the conditions you have used in the SQL commands or the SQL query, finally you will be getting the one particular table as a result. Okay, the final will be the one result or one resultant table based on the conditions or based on the query that you have written. Okay, that is what the point here. Okay, so this property makes the algebra closed. That means all object and relational algebra are relations. We'll be considering everything as a, all the table and everything as a the form in the name of relations. Okay, then the algebra operations thus produce a new relation. So after completing or the finishing your all the relational algebraic operations, you'll be getting a new table or the new relation. Okay, so again, suppose if you want to perform any other relational algebraic operations on your output table, again you can do it. Okay, that is what the point here. That is, these can be further manipulated using operations of the same algebra. Maybe you can use the relational algebra again to manipulate your resultant table. Okay, so to get your accurate results, right? So here the next point is, when you are studying about the relational algebra, there will be some relational algebraic operations will be there. When you combine relational algebraic operation, then you are going to make it as a relational algebraic expression. Okay, so here a sequence of relational algebra operations forms a relational algebra expression, right? So maybe you would have studied about what do you mean by expression in mathematics. Okay, see in this example, for example, you can see a plus b is one of the operation and b minus c is the another operation, right? When you combine these two, a plus b into b minus c, and this will actually forms a expression. Okay, this we call as an expression, right? Similarly, using the relational algebraic whatever the concept we are studying, whatever the for example, select, projection, rename, so this can be combined into a single query or the single expression that we call as a relational algebraic expression. Okay, the result of a relational algebra expression is also a relation that represents the result of a database query. Okay, so the final, when you execute a relational algebraic expression, the final result will be also a complete table. Okay, that we call as a relation, right? Then, so here first we'll discuss about the unary relational operation select. Okay, this is the first one. So this select relational operation is more or less equivalent to the select statement that we use in the SQL commands. Okay, so here for this select relational operation we use the symbol sigma. Okay, so the sigma symbol is denoted for select operation, right? Sigma selection condition, or so R stands for the relation. That means your table. Okay, so here the symbol sigma is used to denote the select operator, and then the select condition is a Boolean conditional expression specified on the attributes of the relation. So it is based on the selection condition. Whether it is a true, then you are going to select the set of tuples or records from the given relation, or otherwise you'll be getting the null value. Okay, so it is actually working based on the Boolean. If the condition is satisfied, if it is true, then you are going to get some set of tuples from the available relation or the table. Otherwise, you will not be getting any result there. Okay, so tuples that make the condition true. When the given condition is true, then the set of tuples will be selected. That is appear in the result of the operation. So that will be, you will be getting as a result. Suppose if the condition is false, then it is discarded from the result of the operation. That is, no tuples or no records will be written from the given relation or the table. Okay, then, so in the select operation, so how we can use the select operation? That is, select operation is used to select the subset of the tuples from the relation based on the selection condition. So you just, maybe you would have experience with select statement. Suppose in a table you have 100 records. Okay, in a table, in the student table, you have 100 records. So based on the condition in the select statement, suppose if you say select student name from student table where condition that is department equal to XYZ, okay, or department equal to computer science. Okay, something like that. Suppose if you, among the 100 table, only 20 tables are with department value equal to computer science, that alone you will be getting. Okay, able to understand? So when you use your select statement, you would have experienced, right? So select statement will just get your exact, based on the condition, you will be selecting the number of tuples. Okay, here the selection condition acts as a filtering. Okay, among the 100 records, you will be selecting only the 20 records or 20 tuples which matches with the filtering condition or given selection condition. Okay, so keeps only those tuples that satisfy the qualifying condition, and tuples satisfying the conditions are selected, whereas the other tuples are discarded. So we just discussed in the previous slide. So when the condition is matching, only the matched tuples you are going to get as a result. Otherwise, if the condition is not matching, then all the remaining records will be discarded. So in this example, the 20 records alone will be filtered based on the condition. That is, you are giving condition as department equal to computer science, and the remaining 80 records among the 100 records in the table will be discarded. Okay, that will be filtered out, right? So you can see the example here. We'll consider here employee table. In the employee table, maybe you can have number of records in the employee table, and here the condition is sigma, that is select, department number equal to 4, and then employee. Employee is the relation name, that means the table name. Okay, so here you are giving the condition, that is department number equal to 4. That means what? From the employee table or the employee relation, will be filtering only the records that matches with the given condition, that is department number equal to 4. Okay, so then again, the one more example, the sigma salary greater than 30,000 from employee. See here also we use the relational operator, that is salary greater than 30,000. That means what? In the employee table, in the salary attribute or in the salary column, whichever the record is having more than 30,000, those particular records alone will be selected. Okay, the remaining records will be discarded. Right? Able to understand? Now, here the other properties of your relational operation, that is select. So in what are the other different ways or different combinations you can use the select operation? So what are the properties, okay, that we are going to discuss now, right? So here the select operation sigma select condition produces a relation, yes, that has the same schema, same attribute as set. It is so obvious. When you apply the select condition, based on the condition you are going to get the filtering, and what all the schema is used in the relation, or the same schema and same set of attributes you are going to get in the resultant table, okay, the final output table, right? So here we see the properties one by one. Select sigma is commutative property, okay. This properties you would have studied in mathematics. Commutative property, that means you can just replace the condition as you wish, okay. But again, even if you replace the condition, then you will be getting the same result. For example, here sigma condition 1 and sigma condition 2 and then R, okay, equal to sigma condition 2 and sigma condition 1 R. So here during the evaluation, what will happen here? First, the relation given R, the condition 2 will be performed on the given relation R, okay, and then you will be getting some set of result based on the condition. There will be filtering and you will be getting certain number of tuples or the records from the relation R, okay. Given relation table, you will be getting the certain number of tuples. For example, if you have 100 records in the relation R, and based on the condition 2, suppose if you are able to get only 50 records, and that will be your result, okay. Then again, on the 50 records, that is selected records, you are performing the condition 1, okay. Able to understand? So first filtration is based on the condition 2. You will be getting somewhat less number of tuples based on the condition, and again this number of tuples you are again performing the condition 1, okay. So for example, in the first stage you will be getting 50 records, and when you apply the condition 1, maybe you will be getting 10 or 20 records based on the condition, okay. The same thing, you suppose even if you change the condition in ordering, right? So in this left side, you will be performing the condition 2 first with the relation or, and then on this result you are performing the condition 1. But whereas here in the right hand side, you'll be performing the condition 1 first on the given relation, and you'll be getting certain output, and based on that intermediate output you'll be performing the condition 2, okay. So you can able to understand, right? So there is a swapping. So but again, in the commutative property, both the result will be same, okay. So once you understand this, then it will be very easy for you to understand the remaining concept, remaining properties, okay. The next one is the cascading sequence of select operations may be applied in any order, okay. Suppose the order of conditions can be applied in any order. So even if you change the conditions in any order, you'll be getting the same result, okay. So you can see here condition 3 first executed, and then next condition 2, and then next condition 3, and here first condition 1 is executed, and then based on that the second one, condition 3, is executed, and then the condition 2 is executed, okay. But anyway, both the operations will give you the same result, okay. The next comes to the conjunction of all the conditions. Maybe instead of giving the conditions in this format or in the select statement or in the select operation, what you can do, you can replace with AND operator, okay. So this AND operator, you can see here, condition 1 and condition 2 and condition 3, okay. In this way you can replace. This is the another property in the select operation, okay. The number of tuples in the result of a select is less than the number of tuples in the input relation R. So generally when you apply any condition, if the condition matches, for example in the initial relation or in the table you have 100 records, and when you apply certain condition, obviously based on the condition you'll be mostly getting at least one lesser than the given set of attribute or the given set of records, okay. Able to understand? So that is what the point here. And now we'll discuss one simple example. This is what the employee table is given. You can see here first name, middle initial, last name, and SSN and birth date, address, sex, salary, and super SSN, department number. Okay, these are the attributes or fields are given in the employee table. Okay, F name for first name is one attribute or the field, middle initial is one attribute or the field. Okay, so you will know what is a field and what is the attribute. Okay, so column, field, or attribute, anything you can use. Okay, so here we use this query relational algebraic format: sigma department number equal to 4 and salary greater than 20,000, or department number equal to 5 and salary greater than 30,000 from employee. Okay, so this is how we know you write your that is relational algebraic expression query. Okay, so this will be working equivalent to your select statement in your SQL query. Okay, SQL commands. Okay, so now what will happen? You have used department number 4 and department number 5. So department number 4 and department number 5. Okay, so there are how many department number 4 are there? 1, 2, 3. Okay, there are 3 department with department number 4, and then there are 4 departments with department number 5. Okay, so only one is there, one will be discarded because we are not including one here. Okay, and then the second, what is the second condition? Salary. Okay, the department number 4 and you are combining with 25,000. So department number 4 with 25,000 greater than 25,000, so this will be discarded and this will be selected and this will be discarded. So only one record will be selected based on this given condition. And R, we use R, and department number 5 and then salary greater than 30,000. Okay, so department number 5, salary greater than 30,000, no, it is equal to 30,000, so this will be discarded, and this one will be selected because it is greater than 30,000, and again this one will be also selected, this one will be greater than 30,000, and this will be discarded. Okay, so this particular record and this particular record, and in the fourth department number only one record. Okay, so from the employee you'll be getting this as your result. Okay, you can see here the result query. So the entire record will be selected based on this condition. Okay, this is what the entire record, right? So you have the first name, middle initial. So what are the attributes and what are the records are there, what are the fields are there in the parent table or the given table, as it is you are getting only the records or the tuples that matches with the given condition alone will be selected in your resultant table. Okay, so that's what from the department number 4 only one record has been selected based on the given condition, and then for the department number 5 there are 2 records have been selected based on the given condition. Okay, able to understand now? See, now we use the tuple for this particular selected records. Okay, so here the tuple meaning that is whatever the record or whatever the rows you are selecting based on the condition, then we can call it as a tuple. Okay, and so next one is we are going to discuss about what in way project. Okay, so far in the select statement or the select operation, relational operation, the operations are happened in the form of horizontal wise. Okay, you can see here. So after performing the select operation, all the records that is in the horizontal, we are actually getting the result. Okay, so entire record we are getting, right? So the select operation will be performing in the horizontal basis or in the record wise. Okay, that we call as a horizontal partitioning, right? Then suppose in the projection, it will work in the kind of reverse. Okay, the project will work in the vertical, that is in the column wise, right? You know what is a column and what is a row, right? So column is the vertical positioning. So the entire column will be selected based on the given condition, right? So it actually the projection will work in somewhat different manner, right? So here the project operation is denoted by pi symbol. We use the pi symbol. There we use sigma, right? So this operation keeps certain columns attributes from a relation and discards the other columns. The similar thing, like based on the condition, the set of columns will be selected, and whichever the columns are not in the condition, then that will be discarded. Okay, so the project creates a vertical partitioning. The list of specified columns attributes is kept in each tuple. Okay, the other attributes in each tuple are discarded similarly. So what we discussed in the previous select, the same thing applies here also. And this is the example here. Pi, that is you are projecting last name, first name, salary from the employee. Okay, that means this will be working in the vertical partitioning, that is vertical direction. Okay, the entire column or entire attribute will be selected here, right? So what are the operation, that is the properties we use here? This general syntax is projection attribute list or. Okay, that is pi is the symbol used to represent the project operation. Then attribute list is the desired list of attributes from the relation. The same thing what we discussed. Okay, so here is a symbol used to represent the project operation, and we have the attribute list. Okay, the project operation removes any duplicate tuples. Suppose if you have any duplicate tuples in the record or in the table, given table, that will be eliminated. Okay, so this is because the result of the project operation must be set of tuples, right? Sorry, project we are talking about again, right? Okay, fine. So the next one is the project operational properties. As we discussed in the select properties, so we can see the project properties also. Here the project properties will work somewhat differently. So where the sigma, that is your select, is commutative, but here project will not support commutative property. Okay, so that means even if you replace or if you change the order, and you will be getting the different result. Okay, so here the list of attributes includes a key, then the number of tuples a result project is equal to the number of tuples in R. So based on the condition, you will be getting either the equivalent to your given relation or less than the number of attributes or columns in the given relation. Okay, so project is not commutative, as we said already. So maybe you will be getting different result, right? Then next one is we'll just discuss about the example to understand the project. Here the example is given, that is pi, last name, first name and salary from the employee, and after executing this relational algebraic expression, then you will be getting the result. Okay, so you can see here L name, F name and salary. There are only 3 columns or 3 fields are given in the projection. As we said, this projection will be working in the vertical partitioning. Okay, so now we can see all the records in the L name, F name and salary will be produced here. Then one more point is it is actually disallowing duplication. Okay, suppose you have more duplicated values, that will be discarded. Okay, and see here the relational algebraic expression, how we can make an expression that we already said. When you are combining more relational operations into a single form, then we can make it as a relational algebraic expression. That means in certain situations you need to combine select and then rename and then projection. All this you will be combining. Okay, when you combine this, the order of execution based on the evolution, you will be getting some kind of intermediate results also. Okay, right? So that we are going to discuss now. So when you are going to make a relational algebraic expression, obviously you will be combining select project or select rename or anything. Okay, so any combinations will be there. When you combine all this, you will be getting your in the form of relational algebraic expression. Okay, so that will give you the intermediate result, right? So we are just going to discuss what is a intermediate result, right? So here the single expression versus the sequence of relational operations. In the single expression, for example, to retrieve the first name, last name and salary for all the employees who work in the department number 5, we must apply a select and project operation. Okay, so first name, last name and salary of all employees who work in the department number 5. Okay, so we are combining department number 5 also. So we need to apply 2 conditions, that is 2 relational algebraic expression. One is pi and another one is sigma. Okay, so here department number equal to 5 from the employee you are selecting, and based on this condition you are going to display the first name, last name and salary of your employee table. Okay, so we have to perform two operations here. Okay, so here in the intermediate results, first you will perform the select operation with the given condition, and here department number equal to 5 from the employee, and this will be fetching the number of records and will be stored in the temporary intermediate result. Okay, DEP 5 underscore EMPS. It's actually a name given to store your intermediate data. Okay, so in the previous example we said there are 5 records which matches with the 4 records, I think, right? So there are 4 records which matches with the department number 5, right? So thus those 4 records you'll be getting will be stored in the department 5 underscore EMPS, and then from the among the 4 records you'll be selecting. So you can see here department 5 underscore EMPS. That is, this is the intermediate result. This intermediate results you are performing again the projection operation. Okay, you are not performing the project operation to the entire employee table. Instead, you will be performing the project operation with the intermediate result values. Okay, so here you'll be getting F name, L name, salary for the department number 5. Okay, right. So on the rename operator, next one is rename operator. Rename, some situations if you want to rename your relation or the table. Okay, whenever we talk about relation, it refers to the table, right? Able to understand? So if we say relation is representing the table, right? So if you want to rename the table name, or if you want to rename the attributes in the table, okay, hope you're able to understand, right? So you can rename the table name, and then you can rename the attributes in the table. Okay, so suppose if you want to rename using the relational algebraic concept, you can do it that also. So here in the rename, the general rename operations row can be expressed by any of the following forms. So maybe you can make use this symbol row of S, B1, B2, and Bn, and then R changes both. Suppose if you want to rename both relation name and then your attribute name, okay, you can use this format. So here the relation name to S, that means the relation name is changed to S, okay, in this name, and then the attribute name will be changed into B1, B2, Bn. Okay, this is one option. And then second option is only you can rename the relation alone. Or suppose if you want to keep your attribute name as it is, then you want to rename only the relation name, then you can use this use this particular format, that is row S and then or. This is actually going to change your relation name into S. And then the other alternative is, suppose if you want to keep your relation name as it is, then you want to only change or rename the attributes. Okay, so that is also you can do using this format, that is row B1, B2, and then Bn, and then R. Okay, it is actually changing the names to the given attribute name, new names. Okay, you can see here example. Here first name, last name, and salary, and this one operation. So here this is actually the first one is from the given employee table. When you perform pi F name, last name, salary, department number equal to 5, and then employee. Okay, so this is actually the previous slide we discussed. We apply the department number equal to 5, and then we are going to select the project the 3 columns alone. Okay, in the 3 columns you have the first name, last name, and salary. Okay, then in the second one using the intermediate relations and renaming of attributes. Suppose if you want to rename the F name into first underscore name, and then if you want to rename MINT and then to last name. Okay, so you can do like this, right? So you can perform like this, that is the first name, last name, and salary. You can filter this, that is you can filter like this, right? Then the next one is we are going to discuss about union. Okay, we are going to apply the set theory. Union operation, maybe you would have studied in even the higher secondary level in the mathematics. Union, that is A union B, B union C, right? Something like that. So you'll be having some set of values, and this set of values can be combined using the union operation. Okay, the binary operation is denoted by union. So why we are calling it as a binary? You need a two different set or two different tables, right? The previous one is unary, so you can use the only one table or only one relation to perform those unary operation. Okay, that is your select, project, and rename. But whereas this union, to perform the relational algebraic set theory, you need two relation or two tables. Okay, so that's what we call as a binary operation denoted by union. So here the result of R union S is a relation that includes all the tuples that are either in R or in S or in both R and S. Okay, so when you combine two different set values, then generally what you will do when you combine these two, the resultant will be what are the elements that are present in R and what are the elements that are present in S. So everything will be combined. Okay, so suppose if the element which is common on both, only one particular element will be considered. Okay, so that's what in the set theory, right? That means duplicate tuples are eliminated. Suppose if you find any particular tuple or record which is present on both the relation, that is R and S, that particular tuple will be eliminated. You'll be getting only one. Okay, so here the two operand relations R and S must be type compatible. When you use unary union operation, then this should be a type compatible. You should have a type compatibility, right? That is, R and S must have the same number of attributes, right? Then a relational algebra operation from the set theory union. This is for the example. Here, based on the given example, we'll be getting the different intermediate result. Okay, when you apply the department number equal to 5 on the employee table, and you'll be getting one intermediate result. And when you apply the projection based on this particular intermediate result, then you'll be getting result 1. And similarly for result 2 SSN, you'll be applying this particular intermediate result and you'll be getting super SSN. Okay, so in the result 2 you'll be getting super SSN from the intermediate result, and in the result 1 you will be getting SSN value from the intermediate result. Okay, so you are combining SSN and then super SSN. That means result 1 union result 2, right? You can see here in this example, here this is the employee table, and based on the given condition, only projection, we are using projection, right? So based on the condition department equal to 5, you will be getting the SSN number of all the department number 5. That is, there are 4 records are there. And in the result 2 super SSN, the super SSN we can see there is a duplicate values are there. Okay, so suppose if you say in the second one, department number super SSN value, the super SSN for the department number 5, that is 3334445. Okay, and then you have 8886645. You have this 3334455. There are 3 records with same value, super SSN value. Okay, so we are taking only one, and apart from that you have only one 8886645, right? Able to understand, right? So this 2 you are making it as a union, the result 1 union result 2. So finally you will be combining all SSN value, that is in the SSN field you are going to store you are adding the super SSN value along with the SSN values. And similarly you have the intersection. Intersection will be just working opposite to the union. That is, only the common values that present on both the relation or both the set will be considered. Okay, so you have the relation R and relation S, that is table R, table S, and you have the number of tuples in R and number of tuples or number of rows in S. And when you apply this intersection, and the common, only the both common set of tuples alone will be considered. Okay, the attribute names, the result will be the same as the attribute name in R. That means you should have the common or set of attribute and then the data type also, right? The 2 operand relations R and S must be type compatible. That means when you perform the intersection operation, these 2 must be type compatible, right? Then the relational algebra operations from the set, that is set difference. We are going to discuss about difference. Difference, as you know, just you have 2 different set of values, and if you subtract from one set to the other set, and what is the common value, that will be discarded. Okay, that will be eliminated, right? So that includes all the tuple that are in R but not in S. So whatever the value that are present in the R, or whatever the record or tuples present in the S, will be discarded or eliminated in OR, right? So it is very simple, just subtracting one set from the other set, right? The attribute names in the result will be the same as the attribute names in OR, right? So again, when you perform the difference, you need to have a type compatibility. Then here, these all the after applying union, intersection, and difference, these are the results we are going to discuss. There are two relations are given. One is student and instructor. Okay, when you perform the union operation, you can see this is the result of your union operation. Okay, so here fn and last name and f name and last name, these two values will be joined. Okay, union, right? You are just combining these two into one single that will be stored in fn and ln, right, in the student, right? So this is actually the union. And intersection, you are just going to pick only the common values present in both the table. Okay, you can see here Susan, Yahoo, and then Ramesh, and then Shah. Okay, only these two records are matching on both the relation, so you'll be getting the union intersection. Okay, the next one is first one is union, and the second one is student union instructor, and then the third one is what we have seen now. It is actually student intersection instructor, and then the now in the D table it shows student minus instructor. Okay, that is what are the common data that present that will be eliminated. You can see here only the intersection portion, that is Susan, Yao, and then Ramesh Shah, that will be eliminated from this resultant result. Okay, so it's a different combination. So then again in the E table it shows instructor minus student. Okay, in the instructor minus student, the whatever the data that is available in the instructor, that will be considered, and it is just going to minus the student data. Okay, next we shall discuss about some of the properties of union, intersection, and difference. We have discussed already some of the properties of union and then intersection. So now in this slide, just you can see both union and intersections are commutative operations. That means you can just use the set theory in the union. That is R union S equal to S union R. Suppose you have a relation R and relation S, and if you perform the union operation, and suppose if you take the left side relation as S and then right side relation as R, and even if you make a union operation, then both the result will be getting as same. That is what the commutative property. Okay, so then again, even if you perform the intersection operation, that is R is one relation and S is another relation. Suppose if you have the intersection operation between these two relations, then even in the suppose if you change the order. Okay, suppose if you keep the S relation first, and then if you keep the R relation in the second one, then if you perform the intersection operation, then again you will be getting the same result. Okay, that is what the commutative property says, right? Here both union and intersections can be treated as n-array operation, that is applicable to any number of relations as both for associative operations. Maybe you can combine any number of operations like this. Here you have taken three relations, that is R, S, T, right? So if you perform this R union and then S union T, so S is one relation and T is another relation. If you perform the relation, that is union operation, and then again based on this result, if you perform the union with the relation R. Okay, so both in the left hand side and then right hand side, you will be getting the same result. Okay, as it applies the associative property as well as the commutative property, you can just add any number of relation as mentioned in the slide. Okay, so here also R intersection S and then intersection T. Even if you replace the order, you will be getting the same result. That means whatever the operations you perform the left side, and then whatever the operations you perform the right side, both will be giving you the same result. Okay, so the next one is the minus operation is not commutative. That is, if you, because in the minus operation, what you are doing, you will be deducting or subtracting the set of rows or tuples that exist on the mainly from the left hand side relation. Okay, for example, here in the R relation, you will be taking, and whatever the tuples available in the S, you are going to subtract with the R. Okay, so if you if you apply the commutative property likewise, that is s minus r, you will not be getting the same result. Okay, because in the minus operation you will be mainly concentrating the relation that is present in the left side. Okay, that's why this particular minus operation is not supporting commutative property. Okay, so next we will discuss about the Cartesian product operation. The Cartesian product operation, maybe you can use this R and S. R is one relation, and it is the S is the another relation. So as I told you already, relation is nothing but representing a table. Okay, so it can be defined as R and S, and then TQ, and then slash T, and T belongs to R and Q. That is Q belongs to S. That is R intersection S equal to null, right? So this is the property we consider in the Cartesian product. That is, when you take relation R and S and you make it as an intersection, it should be null. Okay, so then here the attributes of R of R and then S of S are disjoint. So it should have a disjoint sets. Okay, so here you can see the example relation R and S. So you take the two relation R and S. This one is R and this one is S. Okay, so we said R and S should be disjoint. That is, you'll be having different set of attributes and different set of records. Okay, here A, B, and then here you have C, D, E. And if you perform the Cartesian product, how the Cartesian product is performing, first you will be taking the first record of your first relation R, and then you will be multiplying with all the set of records available in the next relation. Okay, you can see here alpha 1, alpha 10a, alpha 1, beta 10a, okay, alpha 1, beta 20b, and alpha 1, gamma 10b. Okay, so you are taking the first record of your first relation and multiplying with all the records of your second relation. Similarly, once you complete with this, and then you will go for the second record of your first relation, and then you will start multiplying with all the remaining set of records in the second relation. Okay, so likewise, when you perform the product, then you can call it as a Cartesian product. Okay, so this Cartesian product is very much required when you study join operations. Okay, the join operations we are going to discuss in the next video, right? Okay, thank you. Hi learners, please subscribe to my channel and also press bell icon for latest video updates. Please do not forget to like, comment and share. Thank you.